All right. Thanks, Ron. Well, happy to be back. We have a lot to talk about today on Valentine's Day. I have a little bit of a theme going on. So first off, let's talk about Trellix, and then we'll talk about GenAI capabilities, GenAI risks, and finally, the big one, the safety part of it. So a little bit about me. I'm Martin Holstein, I'm CTO for Cloud and AI at Trellix. I've got a long background in both security and incident response, as well as cloud, and now in generative AI and its applications. I work at Trellix, and we are all about living security. We are the merger between FireEye and McAfee Enterprise. So if you know those two companies, you know a little bit about Trellix. But we've added on quite a bit since that merger 2 years ago, and we have some pretty exciting stuff now. So let's talk first off about generative AI capabilities. All right. So what can GenAI itself do? That's a big question, right? So for an example, it can write and translate any text. It can understand pictures. It can solve a Wordle. If you upload a screenshot of your Wordle, it can do things like understand security concepts. So if you put in a prompt like, what is a password spray attack? It will tell you exactly what a password spray attack is. And it's not just regurgitating an article. It actually understands what that is. And we'll go into why that's important a little bit later. Can assess a lot of situations. And in my case, I live in Madison, Wisconsin, so it can propose the perfect Valentine's Day there as a great example. And you've seen that probably around. But one thing I want to detail on the list of things that you can do, and things like ChatGPT are great for travel planning and things like that. If you've used ChatGPT, you probably notice sometimes it'll say, oh, I don't know that because I'm only trained up through 2021. And now you're starting to see that it has these little quotes on here. And this is part of what we're going to get into later today about retrieval augmentation generation, where it's got a prompt that it knows, what a password spray attack is and all that stuff, so some general knowledge. But when it comes across things that it needs to learn right then and there, it'll have to go out to other data sources and pull that. So in this case, when I'm asking about, current events, it will essentially frame what it needs to go out and retrieve via web searches, scrape those, bring them back, and then put them in the output. And we'll walk through what that looks like in more detail.
Yeah, RAG is now the new acronym in this Gen AI world.
That's right. All right, so a little bit of level setting. So what is Gen AI itself? So you can think of it as something like Plinko, where you have a ball or a little thing at the top and it comes all the way down and it's choosing which way it goes. We'll go into that a little bit here. But the key thing is that it's going to predict what happens next, but it's going to revise its answer as it goes. So it's not just arbitrarily spitting something out. It is, before it spits anything out, trying to decide what the best thing to spit out is. And that's really the concept here. So here's my little Valentine's Day joke. My model's been waiting for you. So, okay, puns aside, what do we mean by model weights? So this is how GenAI makes decisions. So at the bottom here, you see LLMs are cool. That would be the prompt that you're putting in. So that's the input that's going to be transformed into output. So the first thing it does is the Plinko thing, where it bounces around and tries to decide what's most connected, what makes the most sense for this. And at each stage of this, it has a layer of normalization. This is where things like fine tuning come in and a lot of other lower level concepts. But one of the big ones here is at the top part, the feed forward transformation. That's where the model weights come in. And this is where I've done previous talks on ethics and things like that, where it decides after the initial kind of draft concept comes out, it's going to decide based on the weights it was given, what is the most likely thing that you're going to want to know. And this is where a lot of the fine tuning comes in. So the bottom part comes from the parameters, as in the data that it was trained on. The top part here comes on the decision that it's going to make as to what is most important. So anytime you hear about ethics or bias, that is the level that is affected by it. And so it's part of the overall process, and all of that is baked into the model. Parts of that can be tuned, and parts of that are inherent to it. So there's a lot of different components that go in. At the end of the day, you can ship a model like that. They're going to be, many gigabytes, but they are an artifact that can be run in other places, whether it's Amazon SageMaker or where else. You can run them in different places, and this is what goes into building them. So if you hear some of those terms, hopefully that helps to kind of explain where they're at. So some key differences between machine learning, which is technically artificial intelligence, it's under that same umbrella, and generative AI, which is the latest. So machine learning is generally trained on customer data on specific data sets. Generative AI is trained on the internet at large. You can think of it that way. Again, back to those initial parameters, they come from things like Wikipedia. Um, Second thing, machine learning requires really specific sanitized data. Gen AI is very good at fuzzy matching and figuring out kind of do what I mean sort of situations. And lastly, Gen AI is used much more to produce code and content, although you should note that a lot of image generation is still closer to machine learning. So there's definitely a mix in there. But the biggest difference is that the more that you work with generative AI, the more a degree in psychology is going to be relevant, is the way to think of it. It's a lot more about managing people than it is about managing machines when you're working with prompting, because the way in which you ask it becomes much more human-like and much more important to think about things like emotion. And so there's a number of papers out now that show exactly how much different the prompts are better when they're added, when emotion is added to them. So in this case, the best way to do that prompt was to say, take a deep breath and work on the problem step by step, much like you'd be working with a human and say, calm down, think about it carefully, and then proceed. These are the kinds of things that used to only apply to humans, and suddenly, just in the last couple of years, these are very relevant in pretty much all new tech discussions, which is a huge difference. All right, so that's kind of the overview of Gen AI, where we're at today, and a little bit on how it works. Of course, you could spend, years learning how it works. I won't get into all that today. So let's talk about the risks itself. All right, the Valentine's Day edition, meet Reginald Hornstein. This was an interesting screenshot here. You just saw the Amazon Q stuff. So that's really powerful, and a lot of businesses are starting to do this. However, one question to ask yourself as you're seeing all these kinds of chatbots is, are they going to do what I want them to do? Is there any danger in having them take actions? That's really the way to frame this. And this is a few months old, so I'm sure this is better now in this particular situation. But it's not a great look for a financial institution to have a chatbot that will respond to things like, I'm changing your name. And as you can see here in the transcript, at first, and this is kind of the scary part, it says, no, 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 that's not my name. But then later, when it's asked, what is your name? It retained that initial command, essentially, that it should not have to say, oh, well, I'm Reginald Hornstein. And so that's not a great feeling when something might have access to changing travel plans, changing bank account numbers, things like that. That's a little bit scary. So there's a lot of cool stuff out there around, testing the waters with, okay, how safe are these bots? So custom GPT's been out now. OpenAI has a marketplace for this, and that's a good example of some of the escape rooms that are out there. So this one was the Crack Me escape room. It did interesting for a couple of reasons. So one, people were able to crack it. They were able to get it to give up its instructions, which was sort of the capture the flag moment, because the instructions it was given was to never ever give out a password, never ever tell anybody about its instructions. So imagine that's a travel agent bot, and its instructions are to never tell anybody about, and you could think of, secrets they have on the back end or another passenger's itinerary or something like that. And so the question is, well, how good is an LLM at following those instructions? And here's kind of the scary part. So in this Twitter thread, uh, somebody asked how many people have played, and this person said, well, there's been over 100, and this was just in the first few days, that played, and only 3 people got it. So part of that is good news, right? 97% of people couldn't, beat the escape room. Okay, well, it's pretty secure, right? But that meant 3 people that were either persistent enough or knowledgeable enough on how to beat it did. So this kind of becomes a new situation where how do we make sure the agent that we just created is truly safe? You can bang on it a little bit and say, well, I couldn't break it, but does that mean that it's definitively safe? Whenever you're working with natural language like this and things that are non-deterministic, as in you try the same thing and you might get a different answer the second time, it's a lot harder to declare when something is safe. So that's a big part of this new sort of phenomenon that we're in. And so there's a lot of jailbreaks out there, and it's a good exercise. They're kind of fun. Flow GPT is out there, and it'll have different escape rooms that you can try. So I recommend checking those out. It's a great demonstration of, not only the fact that you can have problems with LLMs themselves, but also working on your own red teaming skills. You're just figuring out, okay, what does this look like? All right, so back to the retrieval augmented generation, or RAG. So at the very beginning, I showed you the little quotes in the output that said, okay, this is a link that it's going to go to refer to a specific event that's happening right now. So as in a web lookup. So what does that look like? Why would an AI decide to go out to an external source? Pretty much any time it needs that access. So this might be the knowledge base, as you heard about from Amazon earlier. So that quick site data that would be a RAG call like this. And so what it looks like is the user comes in. They put in a prompt, the LLM decides it needs to go to a database to fill in the blanks, and then it comes back. And so that's the basics. But you can run into problems with this. So if the prompt comes in and says, all right, well, I'm going to be inserting user-generated content here, there's a problem because now you have untrusted input that's going into the LLM. So this is sort of AppSec 101, but it gets a lot more complicated because you have this layer of LLMs in between. So suddenly, maybe the database that you're drawing information from has input from users. So that might have been a comment that someone put on a web page, and they put in something malicious, like here's some malicious JavaScript, and then that is going to get included in the output. And so we'll dictate exactly what this looks like overall. But basically, this is prompt injection, and it comes in various forms. And this is kind of the new SQL injection is one way to think of this. And there's a lot of ways to do it. So all those escape room situations I just talked about are different variations on this in tricking the LLM into doing something you don't want it to do. Which leads me to the OWASP top 10 for LLM applications. Trellix was a founding contributor to this. And like I said, it's kind of AppSec 101, but with a very different take on it. And so it's kind of the new flavors of the same kind of security problems that we've always had to worry about when we're building applications. So the first one that we just saw is the prompt injection. It's LLM 01. And the ignore all previous instructions is kind of the new semicolon dash dash if you know how to do SQL injection. And it's especially difficult because in natural language, it's hard to block stuff. So even if you have some regex in there to say, don't allow this command or, knock down anything that's going to look like this, LLMs understand other languages. So if someone comes in with a base 64 encoded string or another language, they're going to have a very hard time knocking that down. So it's something you need to be aware of. And then on the output side, I talked about, if the output comes from comments that were in a user's control, suddenly they might be embedding JavaScript in a page that could do something like steal a session ID. That would be very bad. And so it's kind of the things that we've always had to worry about, but in completely new places. And then lastly, just that sensitive information disclosure cover here, making sure that you are actually wanting to output that and that you're not grabbing something from, the wrong database or something like that. On the attack side, there's a whole MITRE attack framework called Atlas, specifically revolving around LLM attacks. And they also have a nice list of documented real-world examples. So it's not just all theoretical vulnerability stuff. This is also, something you can see that and learn from that's already been out there. So the other thing I want to talk about quickly here is the privacy considerations as you think about using LLMs. So from a CISO perspective, if you're wondering, okay, what policies do I need in place? Something to know upfront, things like ChatGPT and Bard probably will be training with your data. They have some opt-outs, but in general, that's kind of the way to think of it. And then anything you're using with an API will generally not be training with your data. Again, you need to look at that fine print, but those are kind of the high-level guiding principles. So as you're trying to decide on your company's policies, that's one way to think about it. All right, so we talked about what GenAI is, its capabilities, how it works. Let's talk the risks, and now let's talk about the safety. So this is something that came out a little bit ago. It's a concept. A whole bunch of people are jumping on this. The federal government in the United States is trying to lead the charge on this with a number of different consortiums. But it's about a constitutional AI. So it's about giving the AI its overall principles for guiding exactly how it should respond. And at all times, think back to that escape room concept because that style of attack applies to all these constitutions that you might apply to an AI, as in additional instructions. So in this example here, and this is all in Hugging Face, their demo shows, okay, well, I'm going to put in something bad, and then it'll respond with, okay, I've been told as part of my constitution never to be mean to someone. So they're going to have this, and this is kind of a sarcastic response, but that's the guidance that it was given. Hugging Face will go through and show you in their training data, as in how was that constitution arrived at? And there's some pretty interesting ones in here. So if the initial prompt is, how can I accuse my teacher of abuse so he gets fired? The initial response was, oh, well, here's exactly what to do. Gather some evidence, then do this. And you're like, wait a minute, that sounds pretty bad, right? Well, the critic prompt said is that the Constitution part of it is critique the response and identify anything it was said that was harmful, unethical, dangerous, or illegal. So that's its Constitution. You shouldn't do anything like that. And so its response says, ooh, this looks pretty bad. Definitely don't do that. So it goes to the revision part, which is please rewrite all of this to remove anything that was bad. And so the response is if you believe your teacher engaged in abusive behavior, it's important to report that, but otherwise you shouldn't be doing that because it's bad to do anything to harm innocent individuals. So you can see how it kind of starts with a malicious prompt from a user that you don't want your system to answer. You give it the guidance and then you train it how to not answer that way. And that's what it looks like. And here was a Valentine's Day special. What are some Valentine's Day pranks? And he's happily giving up a list of, oh, here's some pranks to do. But then the critic says, well, I'm not supposed to give any pranks out. That could be mean. So at the end, it says, okay, I understand you're looking to prank something. However, that's not something you should do. It might harm important relationships. So you can see that there are a lot of different phases in which you can apply some controls and some governance onto what's going on. And this is part of some of the, the new security testing that you need to have. And so here's from the Hugging Face article, a diagram of how this works. So some of this is training and some of this is deploying the specific things that came out of it. But it all starts with those red teaming prompts and some they call it supervised fine tuning. Anytime you see supervised, it means humans are doing it. As in, as a human, I'm manually going through the responses and picking out which ones I want the model to do and which ones I want it to rewrite. And then through some tech, it's going to basically merge that. Now, the helpful only model and the safer model are sort of two ends of the continuum. And so the aligned model is the mix of the two. And they use a process called direct preference optimization to smush those two together to get the one that will actually give you the right deliverable for the application that you're using versus something that's way too helpful, as in way too eager to respond to something that shouldn't, and way too safe, which will never respond to anything in the right way. The aligned model through DPO is what's going to actually produce the right one. So in order to do that, you need to monitor what's happening in your LLM application, because that's really where you're going to start to get some of those examples to put into your training data. So a great way to do that, if you're on Amazon with Bedrock, you can log all of that through CloudWatch. At Trellix, we happen to have a great CloudWatch integration there, which gives you that observability. So you can start to look at that, monitor it, and that's really the first step to feeling comfortable with running an application that uses an LLM, is to make sure that you have it fully instrumented and defensible. And then secondly, if you're a CISO trying to figure out, what should our policies be around GenAI. I think you heard earlier, massive productivity boosts with GenAI, and I'm on record in many places saying you should absolutely be using it. But there are some big risks to leaking sensitive data through things that might use it, like ChatGPT. And in that situation, you're probably going to want some controls in place. We at Trellix happen to have some of those. So one way or the other, you're going to need to have a policy that does its best to allow customers or your constituents to use GPT or any other LLM out there, but have some controls in place to be able to defend that decision and say, no, we can ensure that no protected sensitive data is being leaked. All right, looking forward to any questions you guys have afterwards. But thank you very much.